Three phases of matter. Penguins live among all three phases of matter: solid, liquid, and gas. The solid ice is a secure place for these birds to stand. The liquid water is where they swim to find food, and the invisible gas, air, is blowing all around them. Ice, water, and air have different properties. Solid ice has definite size, volume, and shape. In other words, the size and shape do not change. That is characteristic of all solid substances. The penguins are surrounded by water in its three phases: solid ice, liquid water, and water vapor gas. Have you ever experienced all three at the same time and place? Let's continue on page 29. Liquid water has definite volume, but its shape changes. It forms waves, crashes up on shore, and flows back to the sea. The volume of liquid water is always the same, but its shape depends on where it is. That is characteristic of all liquid substances. Air does not have definite volume or shape. Air fills in around everything and can take any shape. The ability to change volume and shape is characteristic of all gaseous substances. Why is ice solid? Why is water liquid and air gas? The phase of a substance depends on the relationship between the particles of that substance. In solid ice, the particles are stuck together. They cannot move around because forces attract and hold the particles to each other. These attractive forces are called bonds. They glue particles together. When particles cannot move, the substance cannot change size or shape. In liquid water, bonds hold particles close to each other, but they are not stuck together. The particles move over and around each other. That allows water to flow. Particles in a liquid are packed close together, so the volume always stays the same. But because particles can move, the shape of a liquid can change. Liquids take the shape of their containers. Let's take a closer look at the diagram on page 29. The properties of the three phases. Solids have definite volume and shape and sit on the bottom of their containers. Liquids have definite volume, but their shape changes to fill the bottom of their containers. Gases have no definite volume or shape and always fill their containers. In gas, particles fly around in space as individuals. Particles have a lot of space between them. Because they are not bonded, they spread out to fill a container. Gases have no definite volume or shape. Gases fill any container they are put into. Applying force to matter. Let's look at three samples of matter. One sample is solid, one is liquid, and one is gas. Each sample is made of 39 particles. Each is in an identical container. This is how the particles would be organized in the three samples. A syringe is a good tool for applying forces to samples of matter. We can use a syringe to see what happens when force is applied to a solid, a liquid, and a gas. And the diagram to the right shows a solid, and when force is applied, the particles of a solid are touching and bonded tightly. In a liquid, the particles of a liquid are touching, but they can move. Last is gas. The particles of a gas have a lot of space between them. In the picture below, it shows that this liquid has bubbles of gas floating through it. The liquid and gas have different properties. Let's continue on page 31. Solids and liquids are not very interesting in a closed syringe. They cannot be forced into a smaller space because the particles are already in contact with one another. But there is a lot of space between gas particles. Gas can be compressed. The particles of compressed gases are forced closer together. But there is a limit to how much gas can be compressed. At first, it is easy to push the plunger down. The air inside the syringe feels spongy, but the farther down you push the plunger, the harder the air feels. Why is that? The air particles are flying around very fast inside the syringe. When they crash into the plunger and the walls of the syringe, they apply a force. When the plunger pushes gas into a smaller space, it pushes the particles much closer together. This results in more particles hitting the plunger every second. The particles pushing on the plunger tip make it harder and harder to push the plunger. At the bottom of page 31, we can take a closer look at that. Particles in a plunger. Moving air particles apply a force to everything they hit. The force pushing the plunger down, which is the blue arrows, pushes the particles of air in the syringe closer together. A bubble in a syringe. A plastic bubble filled with air crumples up when you compress the air around it. Can you figure out why? When air compresses, the air particles hit everything with more force. They hit the plunger, the walls of the syringe, and the plastic surrounding the air in the bubble. The plastic pushes on the air inside the bubble. The air inside the bubble compresses, just like the air outside the bubble. The number of air particles inside the bubble stays the same, but the space occupied by those particles, the volume, is smaller. The plastic bubble crumples because its air volume is smaller. This is shown in the diagram at the bottom of page 32, compressing an air bubble. Before the plunger is pushed, the plastic bubble filled with air is spherical. When the plunger is pushed, air is compressed in the syringe and the air bubble.